Welcome to the video about congruent triangles. When we say congruent, we mean triangles, or this would apply to any shape, that are the same shape and exactly the same size. The symbol for congruence is an equal sign with the little squiggle on top. So the squiggle like the similar sign, but an equal sign underneath. So that means they're exactly the same angles, same side lengths, just a copy of one another. When we check to see if two triangles are congruent, we're looking to check for corresponding angles and sides. So remember, corresponding means they're in the same position. Okay, if this angle is in the same position as this angle, and we know that they're equal, then we say they're congruent, those angles are congruent, and they're corresponding. A couple symbols we're going to use. We like to use a little rainbow symbol here to show that that angle is congruent to that angle. And I'll use, if I want to show that this angle, different from that angle, is congruent to this angle over here, I use a double rainbow. Some people like to use an angle symbol with a double dash, or a single dash, or a triple dash. Maybe we'll do this one triple. So the triple dash is congruent to the triple dash here, or you could have done 3 rainbows, say. So those are the angle congruent symbols. The side lengths, I would do one side length is congruent to this side length. This side length is congruent to this side length. And then the triple dash side length congruent to the triple dash side length. So let's look at the rules or the theorems we're going to follow to decide if two triangles are congruent. If we follow the side, side, side congruence theorem, then we're looking to see if all 3 sides, if all 3 sides are congruent to the other 3 sides. The way that we might mark this is we might say that this side length is equal to this side length, that CA is congruent to LO, and that TA is congruent to GO. If all 3 side lengths of one triangle are congruent to all 3 side lengths of the other triangle, then we can say that triangle CAT is congruent to triangle LOG. It would not be correct in this case to say that triangle CAT is congruent to triangle LGO, because we want to list the angles of the triangle in the order in which they're congruent. So since side length CA is congruent to side length LO, we want to list those in the same order. So we'd have this triangle CAT is congruent to triangle LOG by side, side, side congruence. Let's look at the next example. Side, angle, side. Notice the word angle is in between the 2 word sides. So we're looking for triangles that have 2 side lengths and the included angle congruent. Oops. Okay, when we say included, that means in between. 2 side lengths in the included angle are congruent. Congruent. So let's say we knew that angle S was congruent to angle P. and that we also knew that ST was congruent to PN, and that SA is congruent to PU. So then we have this side length, and the included angle, the angle in between, congruent to this side length, and the included angle. So we would say triangle SAT is congruent to triangle PUN by side angle side congruence. Now we have angle, side, angle, sort of the opposite of the one we just did. We have two angles and an included side must be congruent. So let's say we know that this side length is congruent to this side length, and we know that this angle is congruent to this angle, and that this angle is congruent to this angle. Well, we have two angles and an included side congruent to two angles and an included side. So I can say that triangle FUN is congruent to triangle BFA by angle side angle congruence. All right, now we have angle, angle, side. So no longer is the side in between the two angles, but we say that we have two angles and and an adjacent side are congruent. Adjacent means next to, right? So that looks like if we have, say, angle A is congruent to angle X, and angle C is congruent to angle Z. And what if we had CB congruent to XY? So we have angle, angle, side. So since that angle, angle, and side are congruent to this angle, angle, and side, we can say that triangle ABC is congruent to triangle XYZ by angle, angle, side congruence. Please note, change colors for this one. Nowhere in any of these examples have we come across a rule that says if you have an angle and a side congruent, that you can say that you have enough information to show that the triangles are congruent. So what we like to say is there is no angle, side rule. Or if we just wanted to represent that with an image, we would say no of this. Let's look at some examples. So one of the main questions in this whole unit is there enough information? Here we have a few examples where we want to know if there's enough information to say if the triangles are congruent. And if they are congruent, we want to know by what theorem. So we're going to start by saying that all we know about this picture is that this line is parallel to this line. And the little arrows on this line and this line indicate that those two lines are parallel. Well, if I know that those are parallel, then this line AC, I can extend it a little bit, maybe that will help you see it, is a transversal cutting through these two parallel lines. And I know if I have a transversal and two parallel lines that this angle is congruent to this angle by alternate interior angles, and that this angle is congruent to this angle by alternate interior angles. So far I have an angle congruent to an angle congruent to angle, and if I look at this line here, this line is part of the top triangle and part of the bottom triangle. So this line has to be congruent to itself. So what we have is the top triangle with those parts congruent to the bottom triangle to those parts congruent. So we would say that triangle triangle ABC is congruent. Now notice triangle A started with the single angle, so we have to start the next one with the single angle, and we're going to go away. So we're going to say to triangle CDA by angle, side, angle, congruence. Example 2. The only information we're given to start out here is that this line is congruent to this line and that this line is congruent to this line. The other piece of information that you're going to have to deduce on your own is that this angle is congruent to this angle. And if you're saying in your head that that angle CAT is congruent to angle BAG because they are vertical angles, then you're right. This is an angle that is vertical to this angle, so those angles must be congruent. And since we have a side and an angle and a side congruent to a side and an angle and a side, then we can say that triangle CAT is congruent to triangle BAGG by side, angle, side congruence. In our last example, the information that we're given is that this angle is congruent to this angle, that this line is congruent to this line, and we can see right away, sort of like in our first example, that this shared line is going to be congruent to itself. So it looks like we have an angle and a side and a side, and an angle and a side and a side. So you're probably all trying to say that these two triangles are congruent by the angle, side, side theorem. But remember what we said, that this is not a theorem. So we would say not enough information. I forgot an M. Oh man. Information, not enough information to say that the triangles are congruent. That's it for today. Please let me or Mr. Tagg know if you have any questions. There is a gold sheet to fill out where you can summarize the rules from the similar triangles video and the rules here from this congruent triangles video. Have a great afternoon.